Alright, so today we are talking about angle measures. Again, you probably have seen a little bit with this before, but let's just make sure we're all on the same page. So an angle is formed when you have two non-collinear rays that have a common endpoint. In other words, got a ray here, got a ray here. They meet at the same point. That point is called the vertex, and the rays are the sides. So when we are naming angles, we have to pick 3 points, or they'll give us a number that's right next to the vertex. Either way, we can use either setup to name the angles. So for this first question, where it says name all the angles that have B as a vertex, what I'm probably going to want to do is find point B, and then try to draw out my angles. So if you notice, we could draw an angle there. It's going to pass through 3 points, right? It's going to pass through A, B, and D. So I can call that angle A, B, D. I could also have called it angle 1 because the 1 is the one that's inside of that angle. I need another angle that points that has point D, point B as its vertex. So we notice we can draw another line there. This angle is going to pass through the points D, B, and C. The order I write those points doesn't matter except for one thing. The B has to be in the middle. In other words, I have to name the points in the same order that I trace them out when I'm drawing the angle. So as long as the B is in the middle, I named it right. The two on the outside can switch. Alright, so the second one says name the sides of angle 3. So I want to find the 3. Right over here. I notice that angle is this guy right here. So the 3 points that make it up are B, C, and E. And since it says to name the sides, that means I want to name those rays. So I can go from C to B, or it goes from C to E. So remember, we want to start from the vertex and go out because in an array, the order I put the points matters. All right, next example. Find the angle GHL. Let's do this. So where's the G? G is over here. Let's see, H is over here. L is over here, so that angle is going to look like this. So what we want to do is look for the number that's inside of the angle right next to the vertex. So there is the 7. So we're going to call this guy angle 7. Finally, we want to name a point that's on the interior of angle DBK. So interior just means on the inside. So if I find point D that's over here, point B is over here, and K, it's hard to see, but it's down here. So the point that's on the inside would be somewhere over here. So if I'm looking for that point, it would probably be this guy right here. So that's going to be point E. Here's a couple of examples. Use that same map for the next few questions. Alright, so how do we measure angles? Well, we use degrees as our main unit of measurement. Basically, 360 degrees makes up a circle. So 1 degree is if you took a circle and split it into 360 parts. We can classify our angles in 3 ways. So right angles are exactly 90 degrees, and they'll know because they'll put the little box there. Acute angles are smaller than 90 degrees, right? So you may have heard acute little angle. And obtuse angles are the big angles, right? Anything bigger than 90 degrees. All right, so how are we going to use that in an example? Well, usually what they're going to do is give us a picture and have us figure out what type of angle we're looking at. So if I'm looking for MJP, I'm going to find M, J, and then P, and I'm going to trace that angle. So again, notice the J is in the middle because it's the vertex. I noticed they marked it with the little box. So this is a right angle. So then for LJP, I'm going to find L, J, P. So if I trace out that angle, notice that if I start at L and sort of rotate around, that angle is bigger than the one we just were looking at. So since it is larger than a right angle, it has to be obtuse. Finally, NJP, so we got N over here, J over here, P over here, so we're going to trace. This is the smallest angle. This guy is smaller than the right angle we looked at in the first part, so that means this guy is acute. Alright, so you should be able to hopefully try the next few. Use the one we just did to help guide you. The last thing to talk about today is our angle bisector. So the word bisector means cut in half. So anytime you see bisect or bisector, think of it almost like the same thing as midpoint we talked about last time. So in the picture, this line bisects the larger angle because you see how the two sides match, which tells us that W has to be exactly in the middle of that angle. So for a problem like this, we're going to do something similar to what we did with our midpoints. We're just going to label everything that they give us and use that to set up our equation. All right, so what do we know? We know that Kn bisects, so that means this guy is exactly in the middle. We know that Jkn is 8x minus 13. So Jkn. We know that NKL is 6x plus 11. And again, since N is bisecting the larger angle, that means the two sides have to match. So we can say 6x plus 11 has to equal 8x minus 13. And then we can solve from there. We'll subtract our x's once we've got our numbers together. So we've got negative 24 is equal to negative 2x, which tells us that x equals 12. Okay, so last thing, double check, make sure we have what the question was asking for. It says to find the measure of Jkn. So Jkn was this side right here. So if x equals 12, that means the measure of angle Jkn is equal to 8 times 12 minus 13. So we're going to do it just like that. So that means we should get 83 degrees. All right, so we have a few more examples for you to work on your own. And that is all for today. So I will see you guys in class.